Hello everybody. In this video we will going to interpret and determine small changes and approximation of certain quantities. You may refer to the additional mathematics Form 5 textbook on page 70 until 73. Okay, consider the curve y equal to fx on the right. This refers to this diagram. 2 point A, xy, and point B, x plus delta x and y plus delta y are very near to each other on the curve and AT is a tangent to the curve A. Notice that AC is delta x and BC is delta y. It is known that the gradient of tangent AT is the value of dy over dx at point A and equals to the limit when delta x approaches to 0 for delta y over delta x. So where delta y and delta x are small changes in y and x respectively. If delta x is very small, that is delta x approaches to 0, then delta y over delta x is the best approximation for dy over dx. So delta y over delta x is approximately dy over dx. And to find delta y, we can make delta y a subject. Delta y approximately dy over dx times with delta x. So in general, if delta x is a small value, then delta y approximately dy over dx times delta x. This formula is very useful in finding the approximate change of a quantity caused by a small change in another related quantity. The smaller the value of delta x, the more accurate the approximation is. Therefore, we can define that for a function y equals to fx, where delta y is small change in y and delta x is a small change in x. First, when delta y is more than 0, that means delta y is positive. So there is a small increase in y due to a small change in x, that is delta x. Second, when delta y is less than 0, that means delta y is negative, there is a small decrease in y due to a small change in x, that is delta x. Since fx plus delta x equals to y plus delta y, and delta y approximately dy over dx times delta x, we will get fx plus delta x approximately y plus dy over dx times delta x, or fx plus delta x approximately fx plus dy over dx times delta x. This formula is used to find the approximate value of y. Okay, look at this example. Okay, we are given a function y equals to x cubed, and for a we are going to find the approximate change in y, that means we are going to find delta y. Okay, when x increases from 4, that means x equals to 4, to 4.05, that means delta x equals to 4.05 minus 4. So delta x equals to 0.05. Okay, the next step, to find delta y, we need to find dy over dx. So the function given is y equals to x cubed. So dy over dx equals to 3x squared. So when x equals to 4, dy over dx equals to 3 times 4 squared. So you get 48. Okay, to find delta y, we use the formula delta y approximately dy over dx times with delta x. So we get delta y equals to approximately dy dx is 48 times with delta x is 0.05. So delta y approximately 2.4. 4. So in this case, delta y increases from 4 to 48 times with delta x is 0.05. So delta y approximately 2.4. So delta y approximately 2.4 times with delta x is 0.05. So delta y approximately 2.4 times with delta x is 0.05. So delta y approximately 2.4 times with delta x is 0.05. So in this case, delta y increases when delta x increases from 4 to 4.05. Okay, for B, we are going to find the approximate change in x, and we are going to find delta x. So what is delta x? When y decreases from 8 to 7.97, that means when y equals to 8 and delta y equals to 7.97 minus 8. So delta y equals to negative 0.03. Okay, first find the value of x when y equals to 8. When y equals to 8, find x substitute in the function 8 equals to x cubed. So x equals to cube root 8. X equals to 2. And then find dy dx, because y equals to x cubed, same function. So dy dx equals to 3x squared. So when x equals to 2, find dy over dx, get 3 times 2 squared. So dy dx equals to 12. So to find delta x, we use the formula delta y over delta x approximately dy over dx. So that means delta y is negative 0.03 over delta x approximately dy dx is 12. So that means you get delta x equals to negative 0.03 over 12. So we get delta x equals to negative 0.0025. Okay, until we meet again in another video. Thanks for watching.